Right, so here is where we're going to build some functions up using the squeeze theorem. So technically, we can only approach zero from the right side, just because square root does not exist from the left, right? It's undefined when we have negatives, so I'm going to approach from the left side. Does not change anything about the squeeze theorem, other than the fact that when we take limits, we approach from the positive direction. All right, so the first thing we know, and generally a good place to start with trig limits. Actually, literally the first place to start, just try to plug in zero and see what happens. Right, so if I plug in zero, I'm going to get 0 to the fifth times the cosine of 1 over the square root of 0. And this square root of 0 in the denominator here is what's screwing everything up, because you get 1 over 0, you get something blasting off towards infinity and can't take the cosine of infinity. So now that we know that, let's go back to our regularly scheduled program here. So we know the cosine of anything is always going to be bound between positive and negative 1. That's almost always the starting spot for these trig squeeze theorem questions. So 1 over the square root of x counts as an anything. So we could say that negative 1 is less than or equal to cosine of 1 over the square root of x, which is still less than or equal to 1. Right, so we're kind of building up this part here. I've taken care of that. But then, kind of noticing what we have, I don't have a cosine of 1 over the radical of x. I have x to the fifth times it. So then I'm going to take this inequality, and in order to get x to the fifth power times this cosine, I have to multiply everything by x to the fifth power. So multiply, multiply, multiply. And if we're being a little bit nerdy and technical, since we're only plugging in positive values of x, right, x to the fifth power is always going to be positive. We don't have to worry about like flipping any inequality signs. All right, so when we do this multiplication, we're going to get negative x to the fifth power, just negative 1 times x to the fifth, less than or equal to x to the fifth times the cosine of 1 over the square root of x, less than or equal to x to the fifth times 1 is just x to the fifth. All right, so now we've built this function in the middle. The only thing that we're missing is the limit. So now let's take the limit of everything here. So again, I'm basically distributing a limit to everything inside. So that means that we're going to end up with something like this when we distribute that limit. So we're going to have the limit as x approaches 0 from the positive direction, the limit as x approaches 0 from the positive direction, the limit as x approaches 0 from the positive direction. Now, again, we can't do anything with this middle one. If we could have taken this limit, we would have been done by now. So we have to take the limits of the outer pieces. So if we use substitution rule, if I throw in 0, I'm going to get negative 0 to the fifth power. That's just negative 0. That's 0. If I just plug in 0 on for x to the fifth power, I'm going to get 0 to the fifth. So that's also 0. So our endpoints are the same, right? So we're squeezing this function between two zeros. The only way that we can squeeze a function between two zeros is if its limit is also equal to 0. So we would say something like this is 0 by the squeeze theorem, and all of that work that you just did would show me that you understood the squeeze theorem. So there's your limit.